To simplify a complex fraction like this one, or a complex rational expression, the best technique, the simplest technique, is to multiply the numerator and denominator by the LCM of all the denominators in the complex fraction. In this case, that's just x plus 1. So we multiply the numerator and denominator by x plus 1. Now the x plus 1 distributes through the parentheses here. And as you do this, cancel first and then multiply what's left. So here's what I mean. This multiplies times the 2 up here until the x plus 1's cancel and you're just left with 2. And then plus 1 times x plus 1 is x plus 1. The numerator has been completely simplified there. Well, almost completely simplified. Now the denominator, the same thing happens. So the x plus 1 distributes to the first term and over to the second one. So we get 2 times x plus 1, and the plus, and then that last term, the x plus 1's cancel, so you're left with 3. Now in the numerator we have x plus 3, and in the denominator we have 2x plus 2 plus 3. And 2 plus 3 is 5. And so there we have it. That's what this complex rational expression simplifies to. X plus 3 divided by 2x plus 5. Now in problem 79, also a complex fraction, the same technique is going to work. This time the LCM, the least common multiple of all of those denominators, is simply a times b. So a times b distributes through the parentheses here in the numerator and in the denominator. Cancel first and multiply what's left. So we have a divides into ab, leaving b times 5, 5b. Minus 2, because here the ab completely cancels. So the numerator has simplified to 5b minus 2. Now in the denominator, the ab distributes to the first term and the b cancels, leaving 8a. And the plus in the middle. And the ab's completely cancel here, leaving 1. And lo and behold, the expression is now completely simplified. Simplifying complex rational expressions is similar to solving rational equations like this. Same idea, get rid of the fractions. This gets rid of the fractions, gets rid of the fractions. And this, we can get rid of the fractions by multiplying both sides of the equation by the LCM of all of those denominators, which is 15x, because 15x divides into 15x, 5 divides into 15x, and 3x divides into 15x. 15x is the least common multiple, so we multiply both sides of the equation times 15x. It's like you're multiplying the whole equation times 15x. This side gets multiplied and the other side gets multiplied, and the distributive law kicks in and we have to multiply each term. So doing that all at once looks like this. The result first of all, 3x divides into 15x 5 times, so 5 times 4 is 20. And the plus. 5 divides into 15x 5x times. 5x times 3 is 15x. And the equal sign, and here the 15x completely cancels out, just leaving the 7. So there we have an equation, a linear equation we can solve pretty easily. Subtract 20 from both sides, and you get that 15 times x is equal to negative 13. And if I divide both sides by 15, I find then that x is equal to -13/15. So that's the solution to this rational equation. By the way, we have to check that this doesn't make any of the denominators equal to 0, and this certainly doesn't. Only 0 would do that in this case. So that's a valid solution to that equation.